Billy, and today we're going to be talking about how to develop a deep learning model capable of classifying images of cats and dogs. And we're going to be using a pre-trained or a transfer. I'm going to be using a pre-trained model called mobile net architecture or a transfer or learning method. And we're also going to be comparing the transfer learning. The We're going to be comparing the transfer learning in terms of its evaluation with the ordinary deep learning algorithm, and we're going to be checking the accuracies and between the two methods of binary image binary classification. And of course, we're going to be using classifications of images of cats and dogs. And of course, at the end of the day, we're going to be predicting each of the uh, we're going to download an image, all right, from the website to be from a website to be able to predict the classifications of these models using the two models, which is the mobile net and the ordinary neural networks models. And that's what we're going to be doing today. Now, basically, we are going to get our data sets from Kaggle. And before we do that, of course, we're going to have to do some things. First, we're going to have to go to a Kaggle website, and we're going to go to Kaggle website, which is kaggle.com. Of course, if you want to follow this method or if you want to follow this training, it is actually best for you to create an account with them. Create an account with Kaggle, and of course, you can come to this place and go to settings. When you go to settings, then you now go to after you go to set it, go to create new token, and then you say okay. Then it's going to download for you JSON cargo.json folder or cargo.json file, which we're going to use for our project for our work today. All right, so I'm going to go back to my work, and this is you can come here and rename it. All right, this is, you apply the name. This is IPYNB file. So you can see dog versus cat classification. All right. So, and after you've downloaded the JSON file, all right, you're going to come to this place. Of course, you need to have an account with Google. All right, create an account with Google, and then you go to Colab website. You go to colab.google.com. All right, and then you can come to click here and go to new. You can say you want to create new notebook in a drive. All right, it's going to create a new notebook in a drive for you, and then you come and name it here. And then, of course, it is actually very imperative and better for you to come to this runtime and go to change runtime. Then you choose a GPU instead of CPU. The reason why you need to choose GPU is that if you are by the time you are training your model, all right, and you're compiling it, you're going to it's going to be very fast when you are training your model, right? But if you are using CPU, it's going to take you a long time. Like it could take you days, or it could take you hours to be able to finish the compiling. But when you use GPU, it's going to be pretty very fast. So that's actually why I advise you to use GPU. So you can always use GPU free of charge on this particular Google Colab instead of using your IDE. Probably maybe you're using Jupyter Notebook or you're using ordinary Visual Studio Code. All right. Uh, but if you actually have a GPU on your PC, of course you can use GPU. All right. So we're gonna go get started. Like I said, we're going to train the classic. We're going to train the dog and the image classification image dog and cat image. All right, using mobile net. And of course, we're going to also train it with the ordinary neural network models, and we're going to make sure that we actually have the get difference between their results in terms of the evaluation. All right. So the first thing that we're going to do is by that we're going to come to this place. You're going to click on here. All right. Click on this directory. Then come to upload. All right. The cargo that you downloaded, you click on it and they say okay. All right, and then you say okay. Of course, you're going to come to this place and rename this file, all right, as cargo.json. Cargo.json. Right, so I've renamed this file as cargo.json. So it's actually very, very important for you to do that so that you'll be able to use the API instead of you to download about 600 and something MB folder on your laptop. You can actually use these API to upload and to download the data set on your IDE. All right, so let's go to these cats versus dogs. Of course, you can always go to come to these. You can say cats versus dogs. All right, data set. You can go to cat versus dog data set. Click on it. You can see data set here. All right, not the notebook. You can see data set here, and of course you can check on this data set. See the one that has higher relevance. All right, let's say this is 13,334 downloads. All right, let's go down. You can see which one has the highest downloads. You can see 45,000 downloads here. So I think, and this one actually has 522. So we can click on this place. All right, and then of course you can download it here, but like I said, you can actually be better off, all right, copying the you can be better off copying the API. All right, so how do you copy the API? All right, you can go to click on this place and then you say copy API command. All right, and then that will be able to enable you to use these particular work. All right, so the first thing that you're going to do after you have uploaded your cargo.json folder on your IDE environment, which we've chosen Google Colab as. All right, so we're going to come to this place first. We're going to say for us to use the dataset through API, we need to install into the IDE. We need to install Kaggle into IDE. All right, we need to install Kaggle into the Google Colab. So the first thing we're going to do is that we're going to say pip install. Of course, you're going to first type this exclamation mark, something like that, and then go to click on it to the installations. And of course, we've actually done our installation. So you can see here, it's still moving. All right, finally, it's actually finished installing. So we have actually done our installation of Kaggle. All right, and the next thing we're going to do is to do the configurations of the JSON file. But before we can do that, we need to first we need to have uploaded this JSON file in our directory. All right, and after we have done that, then we now go to, if you don't do upload your JSON file, then it's going to yell at you. It's going to prompt up an error. All right, so we're going to, after uploading it, then we're going to now click on run to run it, and then you can see that importing the cat versus dogs from Kaggle. All right, so I think we've actually been able to do that. All right, then like I said, we have copied an API. All right, the API of cat and dog, which is actually this copy API command. So the next thing we're going to do is to copy and paste the command here. All right, when we copy and paste the command here, then we're going to start the installations. The installation is going to start. So instead of you to come to this place and download like 826 MB worth of data sets of pictures of images of cats and dogs, which you want to train, all right, you can actually you can see that it has successfully been executed. So we go to this place and then we can see that we have downloading cats versus dogs.zip. This is the zipped folder. All right, and then we have 90%, which is 806 of 812, and then 100% 812 of 812. So we can see that we have finished downloading our data sets. So we can always come to this code and say ls to be able to know, all right, the number of folders in our directory. So we have 3 folders basically in our directories, which we actually are seeing here. We have the cats versus dogs.zip. This is the zip folder. Okay, we have the JSON folder which we have downloaded initially, and we have a sample data which is like a default folder on the Google Colab. All right, so basically all you just need to do is just to extract. This is a zip folder, so we need to use from zip file, import zip file. All right, we copy this code and then we execute it so that it can be able to extract the dogs versus cats.zip folder which we've downloaded into our data set. So we can see here that after we have done the extraction, we'll see uh, the dataset is actually extracted successfully. All right, we can also come to this place and also try to see how many folders we have in our directories. So we can say that we can have a 1, 2, 3, 4, 5, 6. So this particular zip folder has been unzipped, and we have test1.zip, we have train.zip, and we have a submission, sample submission or .zip. So these are the three folders that we have. All right, we can also see that this train, all right, this train folder, which we actually are concerned about, is also zipped. So the most importantly, first thing we need to do is also, all right, to come to this place and extract it. So we can copy these code snippets from this particular place, and then we'll paste it here, all right, so that we can be able to extract the contents of the train.zip folder. So we've done that, and then all right, we can also go to ls, but I'm not going to do that because I actually have a long way to cover, all right, in this tutorial. So the dataset is actually successfully extracted. All right, so now we're going to now get to the job. All right, so we're going to import s, because we're going to importing as os. All right, is actually so that we're able to use a directory to be able to access into how to gain access into the folder, which is the train. All right, we have actually been able to extract this train.zip and it actually become here. So we need to import OS to be able to access it. So we have the path, directories, and the files, which is this, which is how do we get this place? All right, all we just need to do is just to come to this train, right click and copy path. When we copy path, and then we can now paste. You can now paste it here. Control V. All right, that's all, and then we run. All right, so we're going to the file count is equal to len of files. Then we're going to print the number of images, all right, in the entire train. So the number of images in the entire train folder is 25,000. All right, so and then we have print file names is equal to os.listr, which is the content, which is, like I said, this is the name of the path. All right, then we print file names. Let's print the file names, and let's see. These are the file names that we have. We have the dogs, we have the cats, we have the cats, we have the cats and dogs and cats. So we have a lot of names here. All right, so these are the names of the items that we have in a folder train. Now, importing all required dependencies. Basically, we need to import NumPy. All right, we need to import PIL. All right, uh, PIL is actually going to be is actually what we can use to do our image manipulation. We have matplotlib to be able to display our image. Of course, we need to have MP img actually in our folder to be able to do imread and imshow. All right, so we need sklearn to be able to split and test and to be able to do training, and then of course we have these patches. All right, it's actually also very imperative because sometimes some of these commands may not effectively work in our Google Colab, so we need some commands to make it work. Unlike probably maybe when you run this data set, when you run this data set on your Jupyter Notebook or otherwise. All right, but this is a Google Colab, so we need some things to be able to make it run. First, we're going to start with img to be able to display the image of cats and dogs. All right, that is actually present in our in this folder. So we have img is equal to mpimg.imread. First, we're going to do imread, and then implt is equal to plt.imshow image. We're going to put this image here. Then we're going to say, so this is basically this is a dog. This is dog dot 829. For how did we get these 829 for? We can just pick anything from here. Let's pick this one. This is a dog. This is the image of a dog, and so we can just copy it here. All right, and then let's check this dog. All right, impimg is not defined because we have not run these we have not run this particular page. So let's run it. All right, so let's import it because it is actually making yelling at us or making an error because it has not been imported. So after we've imported this mpimg, So we import matplotlib dot image as npimg and it's not recognized here. So we just need to import them and then let's run it again. So it's going to give us the picture of an image, or the image of a dog. All right, this is an image of a dog. You can see here it has like 300, 308, 300, 350 by 400. That is the dimensions of the dog. All right, let's actually check out the dimensions of a cat. Let's run it. Well, you can see that the cart is this is 140 by 140. We can see that the dimensions of the image and the cart is actually very much different. But we need to ensure that we reconcile the images so that we'll be able to have a very good prediction, so that we'll be able to have um, uh, we're going to have a good result when we run our as when we run our model. All right, in order to increase the accuracy, we need to have a very good we need to have similar dimensions of the images. And of course you can see that this image is actually 3 dimensions. All right, RBG, red, green and blue, which is 3. All right, so we are still going to get there. So it has pictures. It's not a grayscale image which is white and black. It is actually red, green, combination of red, green and blue. Right, so then file names is equal to os.lsistr. All right, that's why we need to install these. We need to import os because we actually use the os to be able to check the content of our. So file names is equal to content of this string, which is this place. Then print the number of images, length of file names, of course. Length of file names means the total number of the file names here. Now for I in range 10, all right, name is equal to file names I. So print the first 3. So let's check it. All right. Now we have total number of images, which is 25,000. So we have 25,000 images. Now we are actually going to print the first three the first 3 characters in the names. So instead of using dog, let's go up here and let's see what we're talking about. This is dog dot 11700 blah, blah, blah. So we only want to print the first 3 characters in our in the name of the in the content or in the train folder. So we have the dog, we have the cat, and these are the things that we have actually printed. And so we have the 3 items now, which is actually put under the file names. All right. So which is the name here. So the name is actually the first 3 letters of the name, which is 3 cat and dog. So here we have the dog count is equal to 0, cat count is equal to 0. Now for img in file names, right, name is equal to, of course, which is what we've actually done here. Now if name is equal to dog, yeah, you say dog count plus is equal to 1, else cat count plus is equal to 1. Now print number of dogs. So what we're going to do is that we're going to this code is actually iterating in the number or in the entire uh, file names. All right, and then we're going to print the number. Is going to take out the name that is it found as a dog and name that is found as a cat, and then it's going to add all of them together. All right, to be able to know the number of cats and the dogs that we have in the folder. So the number of cats of dogs images is actually 12,500 and the number of cat images is actually 12,500. So from here we can see that our data is balanced. All right, we don't need to do any oversampling or any undersampling. All right, our data is balanced, and of course we're going to be able to get a very good result at the end of the day. All right, the accuracy will be actually very high because we have a very balanced data, and that is actually what we are actually after. Now we have creating a new directory. We want to resize our directory because it's actually very imperative for us to resize the directory. If we have folders, so if we have pictures, if we have images that has different dimensions, or it is going to definitely adversely affect or impact the result, impact the accuracy of our model. And of course, it is actually very imperative for us to be able to ensure that all our images are in the same dimensions. Right, they are in the same dimensions in terms of their height and their weight, and also in terms of their type. All right, you don't want to actually bring in images of grayscale and RBG together. All right, it actually has different dimensions. So is that how you convert all these images to grayscale, or you convert all the images to RBG? All right, before we can pass before we can pass into our model. So we're going to create just like you are making a directory, just like if you are in a command prompt. All right, you want to create directory. All right, you say mkdir. All right, you create a directory, and then so we are creating directory inside this content. All right, and inside our root directory, and we're going to name it image.resized. So all right, let's go ahead and run it. All right, so we can come to this place and refresh. All right, to see if it's there. This is image.resized, or we come to this place, click on this code, and then you can come here and you say ls to be able to check the content, whether you have the image resize, which is actually there. So we want to create an image resize, and then what we want to do is I want to check through all our images in the train. All right, and we want to ensure that we convert all those images into a similar image resized at 224 by 224. Right? And we convert it to RBG. So in case we have any other folder that has any other dimensions apart from RBG, want to convert everything to RBG, and then want to save it inside this folder called image resized. All right, so we're going to run it, and let's see how it goes. So it's actually going to take some time to be able to do, because we're talking about 25,000. So we're talking about 22,000 2,000 images. Now we don't want to use 25,000 because it's going to take a longer time. Now basically what we are going to do is that we're trying to like iterate through our models and then select 20,000 pictures at random. All right, and then we're trying to like resize them and convert all of them. Try to open them, then we resize them into 224 by 224. All right, and then we have to convert them into RBG. So we're going to have 224 by 224 by 224, 224, 3. All right, which is actually showing that we have the height of 224, the length of 224, and then of course the dimensions of 3. All right, so that's actually what we're trying to do, and it's going to be inside the folder called image resized, which we've actually done. Now we're going to go to image resized. We're going to print number 5 here to be able to see what we got. Now we can see here that we have a dog. This is the same thing that we did. So basically now we want to check, we want to display the content of the dog to be able to know whether we have actually gotten it right. So we can see here that from here we have 200. Of course, this should be 224, and this should be 224. So we have a similar height and similar width. Now we also want to also run this place here. Let's run it and let's see if we have the same, if we have equal dimensions. Of course, it's 224. So now we have been able to resize our an image. All right, and that's actually very very good, so that we'll be able to to be able to give us a very good result when we do our modeling. Now basically we're going to loop file name is equal to os loop. So we're going to loop through, enter the file names. We're going to make the file names to be the content of the image to resize the labels. Now we're going to check all the labels of course to be able to ensure that all the cards, we're going to make all the labels of all the cards to be 0 and the dogs to be 1. Basically we need to convert all the naming systems, or we need to convert um, both the labels and the data set into what we call numpy array, but we're still going to get there. Now basically, but first we want to first convert them into zeros and ones, because we're dealing with a binary. So that by the time we now want to do the predictions, all right, all the labels that is 0 belongs to cats, and all those ones that belongs to that is 1 is actually dog. So that's what we're going to try to do here. Now let's run it. All right, so we say if label is equal to dog, then we say it's append 1, and if it is actually otherwise, then we say it's append 0, and that's what we did here. So we're going to print file names 0 to 5 file names, and then we're going to have we have the dogs and the cats and that. Of course, let's do the label, and then we have zeros and ones and zeros, and I print the number of the labels. Labels is 2,000. So all our data set has been converted to 2,000 instead of 25,000, because is actually going to be very, very easy for us to be able to do with that number of fives. Now count the number of images of cats and dogs. I want to know the number of the values of in terms of their labels of cat and dogs. Now let's go ahead and run it. So we have zeros and one. Zero is 1044, which is the cat, and then the dogs is 956. So we can actually see that there is a significant balance in our data set. It's not as if it's actually not it's not actually it's seriously imbalanced. So now we can actually use the use these to be able to check to be able to do a visualizations of the counts of the dogs and the cats. And as you can see here, you can see the cat and the dogs. This one is like 1000, and the other one is 956, which is actually very, very much balanced. All right, and then so we want to first now want to go into converting into a number array, because it's actually very, very imperative for us to convert into a number array. All right, if not, it the images will not be able to pass our images into the models, into our model. So we first import CV2, and then we import glob. All right, and that's what we have done here. Then we have content of the images here. Then of course all the extensions, because basically most of the extensions as you can see here, I think are PNG, so they are JPG. So but we decided to add PNG as well. So the files, then we now do the conversions, and then we run this. All right, and then so now want to we've converted it into a number array. Of course, we can also do this conversion when we are doing the train split. All right, so we can just say that x is equal to np dot array. Then we now say cat and dogs. But like I said, we can also do it like this. All right, so let's print. I think we've run this. Let's print dogs images now. This is the dog images. It has actually been converted into number array, as you can see here, right? And we have dogs and cats. The type of dogs and cats is actually number array. Then we have dogs and cat images as well. All right, which is so this is the shape. All right, this is the shape of the cut. This is 2000. It tells you that we have 2000 images in the folder, and the dimension is 224. This is the height, and this is the width, 224. And this three means that this picture is actually in RGB format. It is not in grayscale, and it's not in any other format, but it's in RGB format. So it tells you that this RGB means red, green, and blue. All right, these are the primary keys that actually tells you the combinations of it tells you it tells you that it actually has different colors, or collections of red, green, blue. All right, which actually can give you white and all other colors. All right, so we have cats, dogs. This is transpose. These are some of the things that we can actually use. For example, if you are talking about, maybe you are talking about pandas. All right, maybe pd.read. All right, these are some of the attributes of pandas. So number array also has attributes. For example, if you want to check on pandas, you want to check some things, you can say pd.read, you can say pd.head, you can say pd.tail, pd.describe. All right, these are the attributes of 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 pandas. All right, these are the attributes that you can actually use to check your data set. All right, so the same thing with the same thing with uh, numpy array. All right, it actually has the size. Of course, you can check the size. All right, this is cat and dogs dot size, which tells you the multiplications of 224 by 224 by 3, and this is it. Then we have then we now want to split our data set into x and y. All right, before we can actually pass it through our model. So we have x is equal to dogs and cats, knowing that this actually has been converted into number array, so we don't need to do any conversion. Now y is equal to np dot as array label. So we are now converting this one as well into a number array, which we've actually been able to do now. So this is test and split. Now we have x train, x test, y train, y test. All right, this is we are actually using the test size to be 20%, and of course the training size will be 80%. So and the random state is 2. Of course, we can actually use this one as 2. and that's actually being done because of for the sake of reproducibility of the evaluation of the results. So we have now let's print this x dot shape, and we have x train dot shape, and we have x test dot shape. Now x dot shape will be 2000 by 24 and 3, and of course x train is 1600, which is the 80%, and this is 40%. Sorry, this is the 20%. The test size, which is 400 24 by 3. So we've actually been able to do that. Now, basically, before we can actually do get a very good result, or a very good model result, and in terms of accuracy, then we need to actually do what is called scaling. All right, we need to do actually what is called scaling. Now, if we check our, if we by the time when we read this, all right, we can see here that we have dogs, dogs and cats. All right, which when we actually turn this to number array, we have 200 and 237, 200 and 100, and that and that. So now, if we want to check the let's check these, and let's see the uh, uh, dot max. Okay, let's see dot max. Now it actually tells us that the maximum number of this is actually 255, and let's check dot mean. Dot mean is 0. All right, so before we can actually we want to do what is called scaling, and scaling is actually done in order to ensure that we have it improves the accuracy, or accuracy of our model. All right, and then of course these are the things that we actually need to do in order to actually get a very good result. All right, so first we're going to do x train scaled, and of course x test scaled. So we're going to divide the x train by 255, and we're going to divide the x ten by 255. All right, so let's do that. And then we have actually been able to do that. And so we have print x train scaled. So this is the x train scaled. Now all the numbers are actually between zeros and ones. Actually, this is very imperative, so that we'll be able to get a very good result, and of course to avert overfitting in our model. So it's actually very important for us to do for us to do the scaling, of course sometimes normalization. All right, in terms of preparing our data set before you can actually pass it through, this is actually helping a lot to be able to increase the performance of our model. So let's run this now. In order to build a neural network, first we're going to first build the ordinary neural network. All right, now let's click on we'll click on this, and then this is the mobile net, which is here, and then let's run it. So let's run it. So, and of course we're going to now this is the mobile net, and let's go to the classes is actually is equal to 2, and then the mobile model is sequential, and of course this is summary. So let's run this as well. So we have a model summary. This is the model summary, and of course we're going to go to compiling. All right, we're going to use optimizers of that. Optimizers as Adam. All right, this is the loss, sparse categorical cross entropy, and then the metrics is equal to accuracy, and then so we're going to do the model of fits. All right, to be able, and this is epoch 5. Of course, before we do this, we need to, like I said, we need to ensure that we are using GPU. All right, if not, this is actually going to take us years and days. All right, and can see here that we are getting accuracy of 0.9044, right, and 0.98, 0.9875, which is actually very impressive. Okay, so we can see here that it's actually giving us 98.7 0.9875. All right, and of course this is the find accuracy for test data. Let's find accuracy for test data. All right, for evaluation. All right, and we can see here that we have actually been able to get that test accuracy of 98.25%. All right, then we've actually now we're now building a predictive system for our model. Now this is the input path, which is the input equal to path of the image predicted. Now input image is cv.im read, and then of course cv.im show. Now we can actually see here that we have a cv. We first have to resize our input image to 224 by 224. Then of course we change it to scale. We divide it by 255, and then we do the reshaping. All right, this is the reshaping. This is a 1 and 224 by 224 by 3. All right, in order to make sure that we get our data reshaped, and then we do input prediction. Mode of predict, that's input as reshape. We bring this inside it, and then input label. Of course, this is the ag marks. All right, which actually has to do with by the time by the time predictions is actually done, it will not be giving us 1 exactly. It could be giving us like 0.755 by 0.2. So if you have zeros, if you have uh, zero as the first, if you have a zero as the first dimensions, and one, dog as the first dimensions, and cat as the second dimension. So if you have 0.1, 0.9, now that means that the model is actually a dog, which is the first one. So like I said, now we have now make it to be zero. If it is zero, make it cat. If it is, otherwise, it is a dog. So let's run it. Now this is the path. Now I'm going to have to bring another picture. Let's bring a picture of a dog from somewhere else. This is the cat, and this is the dog that I downloaded from the website. So let's bring it inside. Yeah. All right. Now I'm going to right click here. I'm going to copy path. Let's come here and paste it here. Now let's select this. Let's say enter, and then we're going to see. All right, we're going to see if this dog is a okay. This is a dog. Of course, it shows as a dog. So let's see the prediction. This image is a dog. Fine, beautiful. Now let's come to copy path here as well. All right, and then let's run these as well. Let's run these, and then let me just paste it here and say enter. All right, you can see here what it's going to tell us. They're going to tell us that this is a dog or this is a cat. Of course, this is a cat, so we're going to go down here and we're going to see, okay, this image is a cat. All right, now we're going to shortly be talking about using ordinary neural network for our model. And then we're now actually going to be talking about building the model with train the model with neural network. All right, so we've actually imported all these libraries. All right, model one, and we're actually naming the model to be model one instead of model. All right, so we're going to try to use this relu. All right, and the input shape is going to be 224 by 224 by 3. All right, of course, ReLU is actually very, very effective in training neural network model. And of course, because this is the output. The output is now these are the convolutional layer. This is the flatten. Of course, we're going to flatten the neurons. So this is the first convolutional neurons. All right, it's actually enter into this shape. This is the input. All right, and then we have the second and the third layer, and the middle layer, which is the hidden layers. And of course, we have the output layer. The dense is 1, and the activation is sigmoid. All right, and we are dealing with a binary, so we actually need to use a sigmoid. All right, for our results. And then of course we're going to model1.compile. We're going to compile it. All right, so we're using the binary cross entropy Adam. Optimizer is going to be Adam, which is actually very, very good. And then we have the metrics model, all right, which is accuracy. All right, and then we're going to fit in our model. And of course here we're actually seeing from 52%, and then this is the model evaluation and the evaluation on our test data is going to be 4%. So we have an incredibly low accuracy. Of course, we can actually do the same thing by using this to predict our model. All right, by copying uh, here, and let's create another code, and let's paste it here. So we're going to change this model to model one. All right, we're going to change this model to model one. and to be able to help us to predict. And then we're going to run it. So having run it, we're going to come to this place, and then let's copy the path, and let's paste it here, and let's see what it's going to give us. So basically, we can actually see right now that it is actually very, very important for us to use whenever we are training neural network models. We can actually use a pre-trained models or transfer learning, which is going to give us a very high performance, and it's going to give us a very high output in terms of the evaluations of on our test data. All right, but if we use uh, the new normal neural network, of course, you can see here that because we actually are getting 57% accuracy, all right, which is actually completely low in terms of performance than the pre-trained model which we use, which is the mobile net. All right, we can see here this is the model one that we just run now for neural network. All right, this is actually telling us that this is a cat. Okay, and then of course let's just copy it again, and let's create another, paste it, and let's run these, and let's copy the image of a cat. All right, you can see that this is wrong. Copy path, and let's paste it here, and let's run it. Let's see what it's going to give us right now. So we're running it, and then this is what we've gotten here. You can see here this image is a cat. All right, well, it got this right. All right, and of course it's actually also it actually got this wrong as well, saying this image is a cat, which is actually very wrong. So we've been able to use two different models, the neural network models and also the pre-trained models, and we can see here the while the neural network model is actually giving us 57% in terms of the accuracy on test data, and this pre-trained model, which is mobile net, is giving us 92.25% accuracy in terms of the evaluations on test data. All right, and of course, this is giving us a 54% accuracy on test data. So we can actually see right now that pre-trained models performed excellently better than the neural network model. So if you have any questions, if you have any comment, you can like and share, and I will be actually excited. I will be happy. Thank you so much, and have a blessed day.